Hello dear students, welcome to another session of chemistry most important question discussion from your grade 11 for the chapter thermodynamics. Highest weighted chapter thermodynamics, theory based questions are there, numerical based questions are there. Let us discuss most important question in this discussion. Okay, so thermodynamics, as I told you, we can expect some definition questions like you may study a lot of beginning part, you may study a lot of points like what is mean by a system, what is mean by surrounding, what are the types of system, what are extensive property, intensive property, and state function, path function, heat capacity, enthalpy, internal energy, entropy, Gibbs energy, first law, second law, third law of thermodynamics, SS law, like many statement question we can expect. Okay, so the basic question from the chapter. Let us start the chapter from a simple question, thermodynamics. That is, what is the difference between system and surroundings? System is the part of the universe in which observations are made. For example, if you are going to study about this pen is our system, remaining entire part what we call surrounding. Right. So the part of the universe in which observations are made, that is called system, and the remaining part of the universe what we call surroundings. Correct. So what is system plus surrounding is equal to the total universe. Correct. So this is system and surrounding. So first question, what is the difference between system and surrounding? Okay. Second question, name the different types of systems. You may study there are three types of system, right? There are three types of system. What are they? We have open system. We have open system. Second one, closed system. Open system, closed system, and isolated system, right? Isolated system. Open system, closed system, and isolated systems. Dear all, what is mean by an open system? You know very well, in an open system, the exchange of both energy and matter takes place, right? Both energy and matter exchange takes place from system to surrounding. So if you consider a open cup with hot water, after some time, if it is hot water, after some time it may get cool. That is, energy is transferred to the surrounding. After some time, due to evaporation, the particle can go out. That is called the matter also. The matter also exchange with the surrounding. So what is mean by an open system? The system in which both the exchange of energy and matter takes place with the surrounding. Example, hot water in a open cup. What do you mean by a closed system? The same system, if you consider in a closed container, if it is in a closed container, what we can able to say, the heat can transfer outside. The energy can transfer outside, but no matter, because the container is closed. How energy is transferring, how heat energy is transferring outside? Because the wall is a thermally conducting wall. It's a thermally conducting wall. So what is the wall which is used in a closed system? Thermally conducting wall. Then only heat energy can be exchanged with the surrounding. Correct. So hot water in a closed container. Let us discuss one example for an isolated system. So open system means both energy and matter exchanged, and closed system means only energy exchange. What do you mean by isolated? No matter, no energy exchange with the surrounding. Example, the hot water in a thermos flask. No energy transfer, the matter transfer. That is called an isolated system. Then, what type of wall we are using in an isolated system? We are using an adiabatic wall. An adiabatic wall. Dear all, study what is an adiabatic system. Adiabatic system means there is no heat exchange with the surrounding. Adiabatic wall means there is no heat exchange with the surrounding. So dear all, we studied two terms. Now what is system and what is surrounding. Now we studied what are the different types of system. Open system, closed system, isolated system with example for each. Okay, next question. What is the difference between state function and path function? Very simple. State function, these are 1 mark question. What is state function? Or they will give you example for state function and they ask you which is a state function, which is not a state function, like that. So overall, state function means its value depends only on the state of the system, not on the path which formed. How it formed doesn't matter. What is the state of the system? Whether it is solid, liquid, gas, what is the state? That only depends. That is called state function. So state function which depends only on state of the system, not on the path, how it formed. And what about path function? It depends only on the path of the system, not on the state. Okay, easy to remember the example here. Just remember like that. Path function, okay, path function, the examples are heat and work. Heat and, Q heat, W work done. Path function example heat and work. Others are belongs to, the other main components are belongs to which one? State function. Which all? Temperature, pressure, what is U? Internal energy, what is H? Enthalpy. These all are belongs to which one? State function. Okay, so heat and work done is path function. Temperature, pressure, internal energy, enthalpy, these all are belongs to which one? State function. So study here what is state function, what is path function, study the examples also. Clear all of you? Same one, another question they ask you, write the difference between extensive property and intensive property, give example. Compulsory to study, they are all 1 mark question, sure. What are extensive property? It's a property of a system, or their value depends only on the, or we can able to say their value depend on the size or quantity of matter present in the system. Extensive property mean its value depends on the size or quantity of matter in the system. If it do not depend on the size or quantity of the matter in the system, mean it will be intensive property. So extensive property which is dependent and intensive property independent on the size or quantity of matter in the system. Here also easy to memorize the example here all. For intensive property, just remember these 3 example: density, temperature and pressure. Many are there, basically study this one. Density, temperature and pressure, these 3 are intensive property. Other main factors all are coming under extensive property, which all? Volume, internal energy, heat capacity, enthalpy, entropy, mass, Gibbs energy, everything belongs to which one? Extensive property. So study here what is extensive property, what are intensive property with example. Okay, it's a 1 mark question for your exam, maybe through descriptive type or through MCQ question, which is a extensive property, which is not an extensive property, like that. Okay, next one. Statement of one of the law is a sure question for your school examination. That are, what is or state first law of thermodynamics, or second law of thermodynamics, or third law of thermodynamics. Dear all, first law of thermodynamics is nothing but law of conservation of energy. It is neither be created nor be destroyed, it can transfer from one form to another. That is the law of conservation of energy, or first law of thermodynamics. First mathematical expression for first law of thermodynamics is delta U is equal to Q plus W. Change in internal energy is equal to sum of heat and work done. Yes or no? Okay. What about, so this is first law. What about second law? Second law states that during every course of spontaneous process, the entropy of the universe increases. What? During every spontaneous process. Spontaneous process is a irreversible one and naturally occurring one, right? So during every spontaneous process, the entropy of the universe increases. Let me just discuss a simple example to understand the concept. If you consider the volcano, during volcano, it's a naturally occurring one and it is irreversible. And during volcano, see so much dust particles are coming out. Most of them, the entropy means randomness, right? So during every course of spontaneous process, entropy of the universe increases. That's it. That is called second law. What about third law of thermodynamics? State third law of thermodynamics. Dear all, for a perfectly crystalline solid, the entropy will be 0. For a perfect, perfectly crystalline solid means the particles are orderly arranged. The particles are orderly arranged. There is no randomness. So for a perfectly crystalline substance, entropy, see, there is no randomness, right? For a perfectly crystalline substance, the entropy is equal to 0 at absolute 0 Kelvin temperature. At absolute 0 Kelvin temperature. So it's a direct question for your exam, either first law, second law, third law of thermodynamics for your examination. Dear all, these all are 1 mark question, direct question, study at the definitions. Okay, let's go for the another one. This is the one of the first NCERT question given in your textbook. Express the change in internal energy. You know what is change in internal energy mean? Delta U is equal to Q plus W. Yes or no? Let me, before going to the question, let me tell you one factor. You may study it. When heat is positive and heat, then we can take it as negative, right? You may study that, right? So, dear all, when heat is positive and when heat is negative, if the heat absorbed by a system, generally endothermic, heat is plus sign. When it is negative value, when heat released for exothermic reaction, heat releases, what happens? The Q sign will be negative. So, do you remember all? Q means what? Heat. It can be plus or minus. Plus mean absorbing, minus mean releasing. Okay. Similarly, we have work done. Work done can be positive and negative, dear all. Work done can be positive and negative. If work is done on the system, positive, work is done by the system, negative. Okay, so sign convention is very important. Please keep in mind. As per this, let's see the answer. First question, no heat is absorbed. So what is Q? Q equal to 0. But work is done on the system. So work done will be plus. Right? Work done on the system plus. So what is overall delta U? Delta U equal to Q plus W. That will be W. And what type of wall does the system have? Dear all, they already mentioned no heat transfer. No heat transfer mean what type of wall we have to use there? It's an adiabatic wall. Okay, adiabatic wall. Second question. Let's go for the second question. All. No work is done on the system. So work done equal to 0. But Q amount of heat taken out from the system and given to the surrounding means heat released. Heat released means it's minus sign, minus Q. So what is delta U? Delta U is the sum of Q and W, that is minus Q. And what type of wall does the system have? There is a transfer of heat, right? Heat exchange is happening. Therefore, the wall should be what? Thermally conducting wall. Okay, thermally conducting wall. What about third question? W amount of work is done by the system. So work done will be minus W, and Q amount of heat is supplied to the system, means system absorbed. So Q is equal to plus Q, overall delta U equal to Q minus W. So first law of thermodynamics, the mathematical expression we are using for the answer in this question, delta U is equal to Q plus W. So remember the sign convention of Q and W. When it is positive, when it is negative, what type of wall does the system use? Hope it's clear. Let's go for the next question. All. Show that the relation, there is a frequent asking question for your exam, relation between Cp and Cv. First of all, what do you mean by C? That heat capacity. You may study it. What is heat capacity? What is molar heat capacity? What is specific heat capacity? It's compulsory to know the definition. What do you mean by heat capacity C? It is the amount of heat energy required to raise the temperature of a system by 1 degree Celsius. What is meant by molar heat capacity? It is the amount of energy required to raise the temperature of 1 mole of a substance by 1 degree Celsius. What is meant by the specific heat capacity? It is the amount of heat energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius, right? So 1 here mass is specified. So heat capacity is very important to know the definition. Which all? What is heat capacity? What is molar heat capacity? What is specific heat capacity? Here show the for an ideal gas, Cp minus Cv equal to R. What is Cp? Cp means it is the heat capacity at a constant pressure. Cv, it is the heat capacity at a constant volume. Their difference we have to show that it is universal gas constant R. Let's start from the derivation from the relation between enthalpy and internal energy. We have the equation delta H equal to delta U plus delta nRT, right? Delta nRT. Yes or no? You may study the relation between enthalpy change in internal energy chain, delta H equal to delta U plus delta nRT. For a gaseous system, we will write delta Ng. Suppose you consider the number of moles is equal to 1. Suppose the change in number of moles is equal to 1. So n value we can take it as 1. So the equation will be delta H equal to delta U plus R delta T, right? R delta T. Here n value we take it as 1. So R is a constant. Let us take it out. The change in value is only for temperature. So delta H equal to delta U plus R into delta T. Dear all, we have an equation that for Q or heat capacity, right? So you may study that change in enthalpy is equal to Qp. Change in enthalpy is the heat transfer at a constant pressure. Similarly, delta U is QV. What is QV? Change in internal energy is the heat transfer at a constant volume. So what we can write? QP equal to QV plus R into delta T. Yes or no? We have an equation from heat capacity area. Heat capacity area, we may study that Q is equal to C into delta T. Q is equal to C into delta T. If it is molar heat capacity, you may study Q equal to MC delta T, like that. So Q equal to heat is equal to heat capacity into change in temperature. If Q equal to C delta T, what we can write instead of QP, we can write it as CP delta T. If Q equal to C delta T, what we can write for QV? CV delta T, and plus we have R delta T. What is common in them, dear all? We can cut. Delta T is common in all cases. Yes, we are almost close to our equation. Cp equal to Cv plus R, or we can write it as Cp minus Cv equal to R. This is the relation between Cp and Cv. So Cp is the heat capacity at a constant pressure. Cv is the heat capacity at a constant volume. So dear all, study the definition for heat capacity, molar heat capacity and specific heat capacity. And then this point. Okay, next the derivation. Next question, let's discuss some MCQ point of view. Choose the correct answer. A thermodynamic state function is a quantity. We just discussed now state function which depends only on the state of the system, not on the path. So what is the answer? Whose value independent of path, right? State function mean their value independent of path. Can you answer this question fast, dear all? For the process to occur under adiabatic condition, we said adiabatic condition mean no heat transfer, Q equal to 0. That is which one? Option C, right? Simple question. Now, the enthalpy of all element in their standard state. You may study the enthalpy of formation of elements, right? Of their elements or molecule. You may take it as what? 0, right? 0. You may study the enthalpy of formation of elements. Elements, for example, sodium, carbon, hydrogen, elemental form or molecular form. Molecular in the sense O2, N2, H2, Cl2, like that. Elemental state and molecular state enthalpy of formation is equal to what? We take it as 0. So answer is option B. Next one. Yes, I told you. The theory part, as I told you, these are the definition question they can ask you. And more than this, the theory question you can expect define entropy, define Hess's law. We'll discuss that, okay. In between, we can discuss some 3-4 mark question. Numerical part is there from the chapter. Don't worry, just addition, subtraction questions only. Final answer already I will give you. Just to work out, I will tell you the way how to answer this question. Just try to work out the problem and check the final answer is correct or not. Okay, let us start. The enthalpy of combustion of methane. Dear all, what is methane chemically? Methane is CH4, right? Okay, listen carefully all of you. Methane is CH4. What happen when methane undergo combustion? When methane on combustion, we will get carbon dioxide and water, right? So while balancing, you will get 2H2O and 2O2. Okay. Enthalpy of combustion of methane. Yes, methane undergo combustion. We got the equation. What is second one? Graphite. What is graphite mean? Carbon. Graphite mean carbon. Carbon when undergo oxidation, what we get? Carbon dioxide. Perfect. What is dihydrogen? Dear all, dihydrogen. Dihydrogen means what? H2, right? H2 combined with the O2, what we get? H2O, right? Hydrogen combined with oxygen, what we get? H2O. While balancing, you know, they given for one water molecule, right? So let's balance it half O2. So H2 plus half O2 gives H2O. We made all the equation and their corresponding delta H value during this combustion, how much energy released, that already given in the question, dear all, that is around minus 890.3 kilojoule per mole, minus 393.5 kilojoule per mole, and minus 285.8 kilojoule per mole. Okay, perfect. Question, this is the given data, right? The statement given which we made into equation. Perfect. Now, what is the enthalpy of formation of methane? What is the equation to make the enthalpy of formation of methane? Dear all, keep in mind all of you, enthalpy of formation mean the product should be always 1 mole. Okay, enthalpy of formation, you know, delta HF. They said something about formation mean, please keep the product always 1 mole. Okay, so what do you want to form, dear all? Methane. How to make methane, dear all? CH4. How to form CH4? Very simple. What are the elements in CH4? Carbon and hydrogen. Correct. Carbon exists as C, means graphite. But hydrogen exists as H2 molecule, right? Okay, balance it. C plus 2H2 gives CH4. That's it. You want to make this equation. You have to make this equation by the use of these three. How it is possible? Let's see, dear all. Take it is this equation number 1, this equation number 2, this is equation number 3. Listen very carefully, all of you, how to do the how to make this equation by the use of these three. Let's go. Where is carbon? All of you analyze. Where is carbon? See, all of you, carbon, yes, it is in second equation, right? So take second equation as it is. Second equation is what? C plus O2 gives CO2, where delta H equal to minus 393.5. Next you want 2H2. Correct? Where is 2H2, dear all? Where is 2H2? Yes, we have H2 here, but we want 2H2. We want 2H2, right? So multiply the third equation by 2. So multiply the third equation by 2. If you multiply the third equation by 2, what happen? It will be 2H2 plus O2 gives 2H2O. If you multiply an equation by a value, mean that value you should multiply with the delta H also. So 2 into minus 285.8. Okay. So we made carbon, we made hydrogen. Now what you want? Methane. Where is methane? Methane, methane, methane. Yes, methane is in this equation, right? See, all of you, methane is in the first equation. But we want methane on the product side. Here we have methane on the reactant side. What to do? Reverse the equation. That we have to write it, okay? Reverse first equation. When you reversing first equation, the reactant comes product side, product come reactant side. So CO2 plus 2H2O gives CH4 plus 2O2. What happened when you reverse a thermochemical equation? The delta H sign changes. It is minus, so here it becomes plus 890.3. You made all arrangement. You made carbon, you made hydrogen, you made methane in the reactant and product side. Now we want to get this equation right. What is the equation? Take the sum of all these three. Take the sum of all these three equations, dear all. Let me show you. What you have? All LHS right together. C plus O2 plus 2H2 plus O2 plus CO2 plus 2H2O gives. Right side you have CO2, 2H2O plus CH4 plus 2O2. Let us cut which all are same, dear all, from LHS and RHS. CO2 cut, 2H2O cut. You can see O2 means 2O2. Here also 2O2. What is left? C plus 2H2 gives CH4. We got the equation? Yes. From the given equation, we made this equation. What is the question? How much energy is required for this one? What is enthalpy of formation? You add all these three equations, right, to get that one. So add all these delta H value. Add all this delta H value. That is the final answer. Yes, you will get around minus 74.8 kilojoule per mole. So dear all, these type of question while answering, we have to make enough equation. But simple equation. See, methane on combustion, graphite on combustion, hydrogen on combustion. And formation mean, keep in mind, product should be 1 mole. If you want to form 1 mole methane, take carbon and 2H2. Okay, and make the rearrangement, take the sum and take the value. And check it all of you, minus 74.8. Unit, don't forget, it's given in kilojoule per mole. Clear all of you? Let's discuss maximum questions same per the same type. Okay, next one. A reaction A plus B gives C plus D plus Q. What you understood by this reaction? A combined with B forming C and D plus Q. What is meant by plus Q? Heat liberated. If heat given in right side, product side, means heat liberated, which means the reaction is exothermic. Exothermic, correct. You know, exothermic means what is the sign of enthalpy? We said no, what is the sign of Q? Q, when it is plus Q and minus Q, heat absorb plus, heat release minus. Same. No, enthalpy is the amount of heat energy transferred. So, when delta G, exothermic means what? Heat released. Heat released mean delta H sign is negative. Heat absorbed mean enthalpy change is positive. Okay. Now, is found to have a positive entropy change. What is the symbol of entropy? You know, delta S. What do you mean by entropy? Total degree of randomness of a system, right? Disorderness. They already given delta S is positive. Question, the reaction will be possible. They're all, the reaction can be spontaneous, or they said possible, or they said feasible. All indicate, or the reaction can occur or not. All are related to one thing, delta G, Gibbs free energy. Gibbs free energy should be negative. Then only the reaction can spontaneous or feasible or possible, or it can happen. You know very well. Now we have only the sign of delta H and delta S. How we can prove the delta H G negative or not? We have the equation, Gibbs-Helmholtz equation. What is that? Delta G equal to delta H minus T delta S. Delta G equal to delta H minus T delta S. We know already delta H they given as negative. Minus T into, what is delta S? Positive. They're all, overall this value will be negative or positive. Just think about it. Delta H negative minus T into positive. They're all, this always negative, right? Minus plus minus, big negative, right? So this is always negative at any temperature. So what is answer? It is possible. Yes, delta G can be overall negative at any temperature. So we can able to go with option 4, possible at any temperature. Okay, the system, this Gibbs-Helmholtz equation, they will give you delta H. Let me give you one more question. What happened? Delta H, suppose it is positive, delta S, suppose it is negative. Can you guess it? Delta H positive minus temperature into negative. This negative into negative get positive. It will be delta G overall will be positive, right? Delta G positive means reaction not spontaneous. Okay, not occur, not feasible. Okay, so whether it is spontaneous or not, such kind of question you can expect just to connect with this equation, Gibbs-Helmholtz equation. A simple question: in a process, 701 joule of heat is absorbed. As I told you, heat absorbed mean plus, so plus 701 joule. But 394 joule of work is done by the system. Work done by the system means minus, right? Minus 394 joule. Question: what is the change in internal energy? Change in internal energy is equal to, Q plus W according to first law of thermodynamics. So that is 701 minus 394. That's equal to 307 joule. Okay, you will get 307 joule. So that's just checking whether you know the sign convention or not, whether you take plus, minus like that. Okay, simple question. Next one. The reaction, NCERT question, dear all, keep practicing repeatedly. They are asking this type of question. The reaction of cyanamide with the dioxygen was carried out in a bomb calorimeter. Delta U was found to be. Whenever you get a numerical question, write the given data first. So let us start answer. Given, we can able to say given delta U is given how much? Minus 742.7 kilojoule per mole. At a temperature of, what is the temperature? Standard temperature is given 298 Kelvin. Calculate the enthalpy change of the reaction. Delta H we have to calculate. Dear all, delta H, delta U related numerical questions are must question for your exam. What is the equation we have? Delta H equal to delta U plus delta NG RT. Right, let us substitute. Delta H supposed to calculate. Delta U is given minus 742.7. Unit very careful, okay? Kilojoule is given, okay? Plus, what is delta NG? How to calculate delta NG? What is delta N? Change in number of moles. What is G? Gas. It is calculated by NP minus NR, which means number of gaseous product minus number of gaseous reactant. No need to bother about solid, aqueous, other systems. Only gas. You have the equation, dear all. You have the equation. How many gaseous product you have? Check. This is gas. This is gas. This is liquid. No need to bother about liquid. What is that? Here 1. Here 1. So 1 plus 1. Here 2 moles gas you have in products. So 2 minus. How many gaseous reactant you have? This is solid. Leave it. This is gas. What is the coefficient? 3 by 2. What is 2 minus 3 by 2? 4 minus 3 by 2 is equal to half. Okay, substitute here half into. What is R value? R is called universal gas constant. Dear all, R value is equal to 8.314 joule Kelvin inverse mole inverse. So R value is a fixed constant value. We can substitute 8.314 into 10 raised to minus 3. Why 10 raised to minus 3? Dear all, delta U is given in kilojoule. But R value we have in joule. How to convert joule into kilojoule? Into 10 raised to minus 3. Okay, into temperature. What is temperature? 298 Kelvin. Okay, so what is the relation? Delta H equal to delta U plus delta NG RT. Substitute the all values here. So only something careful here. Delta U given in kilojoule. But our R value we have in joule. So R value convert into kilojoule. Okay. And one more thing, how to calculate delta NG, dear all? How many gaseous product minus how many gaseous reactant? Clear all of you? Do the calculation. Don't use calculator, dear all. Sit and write and practice the calculation. Cross check the value whether it is minus 742.7 kilojoule per mole or not. Okay, let's go for the next one. Calculate the number of kilojoule of heat necessary to raise the temperature. See, we want to calculate the number of kilojoule of heat. We need to calculate heat. Okay. To raise the temperature of 60 gram aluminium. See, their mass is given 60 gram. 60 gram of what? Aluminium. from 35 degrees Celsius to 55 degrees Celsius. Okay, 35 degrees Celsius to 55 degrees Celsius. And molar heat capacity C is given for aluminium is 24 joule mole inverse Kelvin inverse. Okay, dear all. And the final answer, keep in mind, it should be in kilojoule. Okay, here C is given in what? Joule. Don't forget. What is the equation for heat capacity related theory you may study? You may study that Q equal to mc delta T. Q equal to heat equal to mass into here, just normally we are not taking mass here. That number of moles we have to take it, mass, given mass by its molar mass, into heat. See, what is C? Heat capacity. What is delta T? Change in temperature. So let us apply here all. Q equal to mc delta T, right? So Q equal to, what is M? M means what I said, given mass by molar mass, you take it. What is the given mass? 60. You know what is the molar mass of aluminium? Aluminium molar mass is 27, dear all. You know aluminium atomic mass is which one? 13. Their atomic number 13. Their mass is what? 27. Okay. So given mass by molar mass you take it into what is heat capacity? 24 into what is delta T? Change in temperature. So 55 minus 35 is equal to what? 20. So substitute all of you. You will get Q in kilojoule. It is around 1.07 kilojoule. So what is the theory we are applying here, or what is the equation we are applying here for heat capacity? Q equal to mc delta T, where Q is the heat, C is the heat capacity, delta T is the change in temperature, M is the given mass by molar mass. So let us apply this equation. We'll get this numerical question. Okay, next one. What is the enthalpy of combustion? All are NCERT, okay, NCERT question, listen carefully. What is the enthalpy of combustion of carbon to carbon dioxide? What is the equation? Carbon, you know, undergo combustion, what we get? Carbon dioxide, yes. What is the enthalpy of combustion of carbon to carbon dioxide? Is minus 393.5 joule per mole. Okay, during this reaction, you know, this is enthalpy of combustion, right? It's a combustion reaction. How much it is? Minus 393.5 joule per mole. Perfect. Now, question, if so, calculate the heat released upon the formation of 35.2 gram of CO2 from carbon and oxygen gas. Simple question. It's like a stoichiometric question, dear all. This is the equation we have. When carbon undergo combustion, we are getting carbon dioxide. During this, how much energy released? Minus 393.5 kilojoule of, joule per mole energy released. Correct. How much can you able to say, dear all, how much carbon dioxide formed in this equation? You know what is the mass of carbon dioxide, right? One carbon mass 12, 2 oxygen, you know, 1 oxygen 16, 2 oxygen 32 is equal to 44 gram per mole, right? So as per the equation, we can able to say, as per the equation, 44 gram of carbon dioxide formed. Yes or no? As per the equation, 44 gram carbon dioxide formed. In which how much energy released? Minus 393.5 joule per mole energy released. If so, what about 1 gram of carbon dioxide here all? Let me take the 44 into the denominator. So minus 393.5 by 44. Why we consider this one? Because they ask you if 35.2 gram carbon dioxide, for 1 gram carbon dioxide this much energy released mean how much? About 35.2 gram of carbon dioxide into 35.2, right? So minus 393.5 divided by 44 into 35.2 gram. So that is equal to around minus 314.8 kilojoule. Okay. So here it's a stoichiometry question. Carbon undergo combustion, we get carbon dioxide. Correct. We made the equation, that value already given. As per the equation, we have 44 gram carbon dioxide. So 44 gram carbon dioxide for combustion, how much energy released? Minus 393.5 energy released. If so, what about 35.2? Minus 393.5 by 44 into 35.2. That's the answer. All of you, please cross check it. Can you follow, dear all? So study the question, take the question again, practice it. Okay, let's go for the next important question. Calculate the enthalpy of the reaction. We have to calculate delta HR, enthalpy of reaction. The reaction already given that we have the equation for enthalpy of reaction, whether it is standard or not. That's as per the equation you take it. What is the equation to calculate enthalpy of reaction? You know, enthalpy of reaction, please see the given data first. We have actually two equations to calculate enthalpy of reaction. Which equation we can select here? How to identify? Check. See the values given. The given values are enthalpy of formation. Correct? Enthalpy of formation. If they given the data in terms of enthalpy of formation, the equation is sum of the enthalpy of formation of products. Okay? Minus sum of enthalpies of formation of reactants. This is the equation for enthalpy of reaction. Okay, product minus reactant if they given enthalpy of formation data. Okay, and you have to substitute each product and each reactant with their coefficient. Don't forget. Let's see here. Simple question. Delta HR is equal to, they're all first products. Okay, take the sum of all products. Which is the products from the equation? N2O. What is the coefficient? They're all 1. So 1 into, don't forget with the coefficient. Okay, 1 into. What is N2O formation value? N2O. See all of you, N2O formation value 81. Okay, plus. What is the another product we have? 3 carbon dioxide. So 3 into, what is carbon dioxide? Just to substitute all, simple question. What is carbon dioxide value? Minus 393. Okay, minus 393. See, product side over minus, this minus. Now take the sum of reactants. What are the reactant? N2O4. How many? 1, right? 1 into. What is N2O4? N2O4 is 9.7. Okay, plus. What is the other one? 3 carbon monoxide. So 3 into, what is carbon monoxide value, dear all? Minus 110. Yes, all substituted. Just take the sum, subtraction and all. You will get the value minus 777.7 kilojoule per mole. So what is the equation to calculate enthalpy of a reaction if they given enthalpy of formation, dear all? Sum of enthalpies of formation of products minus sum of enthalpies of formation of reactant. But don't forget to multiply with the coefficient both sides. Okay. Next, given that, a simple question from NCERT, given that, hope you are listening carefully, N2 plus 3H2 gives 2NH3. Okay, here for this reaction, enthalpy of reaction is given minus 92.4 kilojoule per mole. If so, what is the standard enthalpy of formation of ammonia? I told you, dear all, standard enthalpy of formation. Dear all, formation mean product should be 1 mole. Enthalpy of formation, if they use the name, mean product should be 1 mole. As per the equation, how many moles ammonia form? 2 moles, right? So we can able to say for 2 mole of ammonia, how much energy required? Minus 92.4 kilojoule per mole, right? If so, what about 1 mole? 1 mole of ammonia means, what is that? It's half. Minus 92.4 by 2 is equal to minus 46.2 kilojoule per mole. What is the only one point you have to identify here? Enthalpy of formation mean product should be 1 mole. Here product are 2 mole. For 2 mole, this much energy mean for 1 mole. It's half is enough. That's it. Clear all of you? Hope you can able to follow me. Yes, let's go for the next important question, dear all. One of the most repeated question in all examination. Calculate the standard enthalpy of formation of methanol. Again, standard enthalpy of formation. What do you mean by standard enthalpy of formation mean? Formation mean product should be 1 mole. Keep in mind. What do you want to form? CH3OH, methanol. Can you make 1 mole of methanol an equation? Simple, dear all. How to make methanol? You don't need to take any equations and all, like a combustion of something, reaction and all. Simple. Methanol, CH3OH. What are the elements in methanol? Carbon, hydrogen, oxygen. Correct. Carbon, hydrogen, oxygen. How carbon existing? C as graphite. So C plus. How hydrogen existing? H2 as a gas. And what about oxygen? O2 gas. Balance it, dear all. C plus. Only 1 carbon we need. How many carbon we need? 4 hydrogen. So 2H2. We need only 1 oxygen, right? Half O2. Don't go to this product side to write some numbers, okay? Product should be 1 mole because they said enthalpy of formation. Okay, yes, we made the equation. Methanol is formed by this reaction. C plus 2H2 plus half O2 gives CH3OH. Perfect. Here already they given the equation to make this. We did one question before, right? Take it, this is equation number 1, equation number 2, equation number 3. They already given the equation with their delta H value. What do you want to do there? Rearrange all of you. They are all carbon, right? Carbon. What is our duty? By using this 3 equation, make this equation. See, where is carbon? Where is carbon in this equation? Can you just cross check it all? Carbon is here, second equation. We need 1 carbon. Yes, we have 1 carbon, right? So second equation as it is, please take it. What do you get? C plus O2 gives CO2, where delta H is equal to minus 393 kilojoule per mole. What do you want next? Hydrogen. Where is hydrogen? Here we have hydrogen, right? But we want 2H2. Here we have only 1H2. What to do? The third equation multiply by 2. So third equation multiply by 2. If you multiply this equation by 2, what you get? 2H2 plus O2 gives 2H2O. If you are multiplying with a value, means that delta H also you should multiply. So 2 into minus 286 kilojoule per mole. Clear all? Next one, what do you want? Oxygen. Where you have oxygen? Analyze all of you. Important. Where you have oxygen, see, oxygen is present in first equation, second equation, third equation. All the equation contain oxygen. Is it like a carbon? No, carbon is only in this equation. H2 only in this equation. But you see, oxygen is there are in all the 3 equations. In such cases, no need to balance oxygen or no need to rearrange oxygen. Automatically it get balanced. Okay. So if that species repeated more than 1 equation, no need to touch it. Automatically it get balanced. Okay. So oxygen you leave it. What is left? CH3OH. Where is CH3OH? CH3OH is in first equation, but we want the CH3OH on the product side. Here it is on the reactant side. So reverse first equation. All you should write it, okay? Reverse first equation. If you reverse first equation, what it become, dear all? CO2 plus 2H2O gives CH3OH plus 3 by 2 O2. Correct. And what happened to the delta H if you reverse an equation? Sign changes. If it is minus, it become plus. Clear all of you? Now we made all rearrangement and take the sum of this equation. All LHS here, all RHS here. So C plus O2 plus 2H2 plus O2 plus CO2 plus 2H2O gives CO2 plus 2H2O plus CH3OH plus 3 by 2 O2. Let's see whether this equation formed or not. Dear all, let's do together. Carbon dioxide, cut it. 2H2O, 2H2O, cut it. See, O2 plus O2. What is O2 plus O2? 2O2, right? You have 2O2 left side. 3 by 2 O2, right side. What we can cut? 2O2, 2O2, we can write it as 1 by 2 O2 plus 3 by 2 O2, right? We know 1 by 2 plus 3 by 2 is equal to 2, right? So this 3 by 2 O2, this 3 by 2 O2 cut, what is left? Half O2 left. So what do you have overall left side? C plus 2H2 plus half O2 gives CH3OH. Yes, we are getting our equation. Making the equation we need, but what is the answer? Final answer. You take all the sum, right? So sum of all this delta H value take it. Take the sum of all these three delta H, that will be equal to minus 239 kilojoule per mole. All of you please cross check it. So here we have a set of equation. By using this one, we are making this equation and take the sum of all the delta H. If it's clear, practice it again. Okay. Next one, dear all. For a reaction at 298 Kelvin, see, they given 2A plus B gives C. A reaction. Delta H is already given how much? 400 kilojoule per mole, and delta S entropy is also given 0.2 kilojoule Kelvin inverse mole inverse. Okay. At what temperature will the reaction become spontaneous? At what temperature delta G will be negative? You know, spontaneous means what? Delta G should be negative, right? That's the one. Carefully listen all. You have the equation for delta G equal to delta H minus T delta S. Gibbs-Helmholtz equation. Apply. See, they are asking exact what's the temperature at which delta G should be negative. Spontaneous. Correct. In order to answer this question, let me consider, you know, delta G equal to 0 at equilibrium. Consider the reaction is at equilibrium where delta G is 0. If delta G is 0, what this equation becomes? It will be delta H equal to T delta S. Therefore, T equal to delta H divided by delta S. Yes or no? Let's calculate temperature, okay? But when you calculating this temperature, at this temperature, you know, Gibbs energy is 0, okay? Keep in mind. So, temperature, delta H is how much? 400. Delta S is 0.2. Yes, you get temperature equal to 2000 Kelvin. But dear all, this is not the answer. The question, at what temperature reaction can be spontaneous? At this temperature 2000 Kelvin, the Gibbs energy is 0, means reaction is at equilibrium. When delta G, you can make it negative. Dear all, answer what we can say, above 2000 Kelvin. When the temperature is above 2000 Kelvin, then see what is equation? Delta G equal to delta H minus T delta S. Correct. So we can delta G when it can be negative, that's a question. Delta H they already given So delta H equal to, you know, temperature is 2000, right? 2000 into delta S. At this 2000 Kelvin, you know, Gibbs energy is 0. When you can make this as a negative value, if temperature is more than 2000, if the temperature is more than 2000, this negative value increase, right? So overall it become negative. So the answer, above 2000 Kelvin, reaction will be spontaneous. Is it clear all? Hope it's clear. Let's go for the next one. For the reaction 2Cl gas give you Cl2 gas, what is the sign of delta H and delta S, entropy and enthalpy? Keep in mind. Dear all, 2 chlorine, correct? 2 chlorine means 2 chlorine atoms join, you are getting a chlorine molecule. Correct? Here whether bond formation or bond breaking, which is happening? Bond formation, right? 2 chlorine atoms join, you are getting a chlorine molecule. Dear all, during bond formation, energy releases. So keep in mind all of you that bond formation means exothermic, energy release while forming a bond. But if you want to break a bond, energy needed, right? So which means bond breaking need energy, which means endothermic. Okay, so bond formation exothermic, bond breaking is what? Endothermic. So here bond formation, right? So exothermic, so energy released. Energy release means delta H sign minus. Correct, dear all? Carefully listen the next. What do you mean by entropy? Total degree of randomness of a system. Means whether randomness increase or not. If there is more randomness or the randomness increases mean entropy positive, randomness decreases mean entropy negative. Okay, clear. Here try to understand. First, whether they asking about randomness means check the state. You know very well, solid to liquid, liquid to gas. You know randomness increases. You know solid restricted movement, little liquid, okay, little bit. gas, very freedom of movement, right? So solid to liquid, liquid to gas, any changes happen or not, check it. Here we can't able to check because both are gas. Generally solid to liquid, liquid to gas, entropy, randomness, increase, positive. If the state is same, then check the number of moles. Here all, as number of particles increases, as number of particle increases, we can able to say entropy also increases. As number of particle increases, then entropy, randomness also increases. So what are the main two factors affecting randomness of a system? Entropy, mainly depends on state and number of particle. As the state increase from or changes from solid to liquid or liquid to gas, entropy increases. Second thing, if state is same, mean check the number of particle. More number of particle means more entropy. See here 2 chlorine becomes 1. Here number of particle decreased. Number of particle decreased mean entropy also negative. So as per this case, entropy and enthalpy both are negative. Let me give you one opposite reaction. What happens? Cl2 become 2Cl. What happened to the sign of delta H and delta U? Can you tell me, dear all? See here 1 chlorine becomes 2, means broken. Number of particle increased. So delta S, right? Delta S will be positive. What about this is bond breaking or bond formation? See here a Cl2 molecule breaks into 2 chlorine atom. Bond breaking need energy, means endothermic. Endothermic mean delta H is what? Positive. Okay, so they will ask you the statements like whether it is endothermic or exothermic or randomness increase or decrease with this type of simple equations. Let's go for a direct question for exam. If the equilibrium constant for, equilibrium constant is Kc is given as 10, then the value of Gibbs energy will be, Gibbs energy is equal to minus 2.303 RT into log Kc. Okay, delta, this is the relation between Gibbs energy and equilibrium constant Kc. Delta G equal to minus 2.303 RT into log Kc. Directly apply. So delta G equal to minus 2.303. Hope you remember the R value in joule. What is the value? 8.314. Let's make into kilojoule into 10 raised to minus 3. And temperature is given at a 300 Kelvin and log Kc value already given, it's 10. Dear all, keep in mind log 10 is equal to 1. So it's equal to delta G minus 2.303 into 8.314 into 10 raised to minus 3 into 300. Calculate the value of delta G. It is equal to minus 5.527 kilojoule per mole. So it's a direct question for exam. Here, study all of you. What is the relation between Gibbs energy and equilibrium constant? Finally, delta G equal to minus 2.303 RT into log Kc. This is the equation for Gibbs energy and calculate directly. And log 10 is equal to 1. Okay, next question. Predict the sign of delta S. Just pause the video. Find an answer, dear all. Here, calcium carbonate breaks to calcium oxide and carbon dioxide. I told you what are the main factors affecting entropy. First thing, state. Whether state is changing or not, check. See, your reactant is solid, but product contains solid and gas. Anyway, the gas is there. A solid converted to gas, more randomness. So, what is the sign of delta S? Yes, it is positive. Okay, if all states are same, then only you have to bother about the number of particles. Clear all? Next one. State Hess's law of constant heat summation. One of the most repeated question for your school exams. State Hess's law of constant heat summation. Let me demonstrate with, or just a small idea let me give you. Consider A is a reactant and B gives a product. Okay, and it's a reaction, so definitely there will be a change in enthalpy of the reaction. So here A is the reactant, B is the final product. Okay, so delta HR is the enthalpy change of the reaction. This is single step. The same process I can carry it out in multi-step, like A first to C, C converted into D and D converted to B. Same conversion but through many steps. Here this is a single step, here delta H1, the enthalpy of the reaction. This is another reaction delta H2, this is another reaction delta H3. As per Hess's law, we can able to write that delta HR is equal to delta H1 plus delta H2 plus delta H3. So what is Hess's law states that? Hess's law states that the enthalpy of a reaction, will be the same if it happen in a single step or multi-step. The enthalpy of the reaction will be same if it happen in a single step or multi-step. Or you can able to say the enthalpy of the reaction for the single step is the sum of the enthalpy of multi-steps. This is called Hess's law of constant heat summation. Just a 1 mark definition question. Hope you clear, dear all. Next question, the enthalpy of formation. This is twisted question, carefully all. The enthalpy of formation of methane at a constant pressure. Enthalpy means what? Heat energy, right? The enthalpy of formation of methane at a constant pressure. That means heat change at a constant pressure is given minus 78.84 kilojoule. At what temperature? 300. What will be the enthalpy of formation at a constant volume? That means we have to calculate QV. Do you remember, I hope you studied in the beginning part we discussed CP-CV relation, right? Heat capacity. At the time I told you delta H is equal to QP and delta U is equal to QV. What is delta H, dear all? Delta H is the heat transfer at a constant pressure. Similarly, delta U means internal energy change is the heat transfer at a constant volume. So there actually delta H is given. What is this? This is delta H and they are asking delta U. Clear all of you? What is the equation for delta H and delta U? Delta H equal to delta U plus delta NGRT we have. Alright. So delta H is already given minus 78.84 kilojoule. Okay, careful. And delta U supposed to calculate what is delta Ng. You know, number of gaseous product minus number of gaseous reactant. Where is the reaction? What is the reaction? Enthalpy of formation of methane. What is methane? CH4. How you can make a methane, dear all? C plus 2H2 gives CH4. You know carbon. You know carbon is solid, graphite, right? But hydrogen is what? Gas. Methane is also gas. So what is delta Ng? Delta Ng equal to how many gaseous product you have? Only 1 mole. How many gaseous reactant you have? 2 mole. That's equal to minus 1. Substitute here minus 1 into what is R value? 8.314. But you see the delta H is given in kilojoule. 8.314 is in joule. Convert into kilojoule. 10 raised to minus 3 into temperature. Temperature is how much is given? 300. So calculate the value of delta U. So what is the point you have to memorize here? QP represent delta H, QV represent delta U. Directly apply the delta H and delta U relation. Find out equation. We have to make it. What is that? Formation of methane mean 1 mole. Yes, we made. Okay, so final answer, calculate all of you. It's around minus 75.5 kilojoule. Okay, next one. Calculate the enthalpy change for the reaction. We have to calculate delta HR. We discussed one question before to calculate delta HR, enthalpy of reaction. I think products minus reactant. Remember where enthalpy of formation is given. And I told you one more equation is there for delta HR. Here we are going to apply. See dear all, in this question they given bond energy data. Bond enthalpy, amount of energy required to break a bond. If they given bond energy data, the equation to calculate delta HR is opposite. That is calculated by sum of bond enthalpies of reactants minus sum of bond enthalpies of what? Products. Okay, this is the equation to calculate which one? Enthalpy of a reaction. So enthalpy of reaction you can calculate in two ways. First equation, product minus reactant. When we can use product minus reactant? If they given enthalpy of formation data. Here they given bond enthalpy data. So the equation is reactants minus product. Let's apply directly. What is the equation? H2 plus Cl2 gives 2HCl. You know H2 means HH. Cl2 means ClCl. HCl means HCl. Right? Their all energies are given in the equation. Directly substitute. So delta HR is equal to. What are the reactants first? What are the reactant? Hydrogen and chlorine. Don't forget to multiply with this coefficient. 1 hydrogen. So 1 into. What is the energy required to break HH bond? HH bond, all are given. HH bond is 433. Okay, plus. What is the coefficient of chlorine? 1 into. ClCl. What is the energy required to break ClCl bond? 244. 244. All reactants over minus. 2 into coefficient 2 into what is the amount of energy required to break 1 HCl bond? 1 HCl bond is what? 431. Substitute all of you. Final answer you will get minus 185 kilojoule per mole. So which equation we are applying here? Bond enthalpies of reactants minus bond enthalpies of product. So don't forget to multiply with it coefficient. Directly substitute. Easy, right? Clear? Okay, next one. Predict in which the following entropy increase or decrease. Carefully. First question, a liquid crystallizes into solid. Dear all, liquid to solid, what happened? You know, liquid to solid means randomness decreases. What happened to entropy? Entropy will be negative. Second, temperature of a crystalline solid is raised from 0 Kelvin to 115 Kelvin. Means, you know, a solid, a crystal means solid. If you increase the temperature 0 Kelvin to 115 mean, you know, solid start to melt. Means solid become liquid. You know, solid to liquid mean randomness increases. Delta S sign will be positive. Third one. See, NaHCO3 solid. Solid converted to solid, gas. Yes, here solid converted to gas. Solid to gas mean, yes, entropy. Solid to gas mean, yes, entropy increases positive. And what about fourth one? H2 gas to H gas. Both are gas. So state is same mean what you want to check? Number of particle. Here 1 mole becomes 2 mole. Number of particle increased. Number of particle increase mean there also delta S is positive. So very simple to identify the sign of delta S. Check the state first, then number of particle. Okay, next question, an NCERT question. If water vapor assumed to be a perfect gas, the molar enthalpy change for vaporization of 1 mole of water. So here what is the reaction? Water undergo vaporization. What is H2O liquid? You know, when it undergo vaporization, you know, H2O converted liquid to what? Gas, right? This is the reaction here. 1 mole. See, 1 mole vapor undergo vaporization. So, 1 mole liquid converted to 1 mole gas. How we analyze this one? Dear, all the reaction is what? Vaporization. Vaporization of 1 mole water. Yes. So, 1 mole water is vaporized. Means liquid converted to gas. At 1 bar pressure, temperature is given. They given 41 kilojoule per mole. What is that? It is the enthalpy change. So, delta H of vaporization is already given 41 kilojoule per mole. Okay. Question, calculate the internal energy. I told you that they will ask you delta H, delta U relation question. What is the equation? Delta H equal to delta U plus delta Ng RT. Substitute all of you. Delta H is 41 kilojoule. Delta U supposed to calculate. What is delta Ng? Delta Ng equal to number of gaseous product minus number of gaseous reactant. See, this is the equation. How many gaseous product you have? 1 mole. 1 minus. How many gaseous reactant you have? No, nothing, right? It's just liquid. No gaseous reactant. So 1 minus 0, 1. So delta Ng 1 into. What is R value? 8.314 into 10 raised to minus 3. Why into 10 raised to minus 3? Because delta H is given in kilojoule. R value, if you want to make it kilojoule, into 10 raised to minus 3 into what is the temperature, dear all? Question, they asking you 1 mole of water is vaporized at 1 bar pressure at 100 degrees Celsius. 100 degree means 373 Kelvin. Correct? 373. This is the answer for first question. Calculate delta U from this one. It is around 37.904 kilojoule per mole. Same theory, they were asked another question. If what happened, 1 mole of water is converted to ice. What? 1 mole of water converted into ice. Ice mean what? Solid, right? What is the value of delta Ng in this time, dear all? Can you guess it? What is the, or no need to guess here, can you find out? What is delta Ng here? How many gaseous product minus gaseous reactant? Is there any gaseous product? No. Solid, right? Is there any gaseous reactant? No, it's liquid. So delta Ng 0. See dear all, delta Ng 0 mean this term completely gone. Delta H equal to delta U. So second question, where delta H equal to delta U, what is the value? That is 41 kilojoule per mole itself. Okay, clear? So what is the reaction here? Water undergo vaporization. Yes, H2O when undergo vaporization, we get liquid to gas. Yes, we calculated delta Ng, substituted. But in second question, liquid solidify into solid. So liquid to solid mean there is no gas. Delta Ng is 0. Delta Ng 0 mean delta H equal to delta U as per this equation. Yes, clear. Next question. A swimmer coming out from a pool is covered with a film of water weighing about 18 gram. So H2O weight is given how much? 18 gram. Okay, it's liquid. How much heat must be supplied to evaporate? Here also reaction is evaporation. During evaporation, what happened? H2O liquid become H2O gas. See, the same liquid is going to this side. So 18 gram liquid converted to what? 18 gram H2O gas. Question, calculate the internal energy. We need to calculate delta U. Okay, delta U, delta H is already given. Delta H is 40.66. 40.66 kilojoule. Okay, unit very careful, kilojoule. Again, which equation? They are all delta H is equal to delta U plus delta Ng RT. Substitute. What is delta H? 40.66 kilojoule. Delta U supposed to calculate. What is delta Ng as per this equation? Delta Ng means number of gaseous product minus gaseous reactant. How many gaseous product you have? See, number of moles not given, but weight is given. How much weight? 18 gram. You know H2O, right? H2O molecular mass also 18 gram. How to calculate number of moles? Given mass by molar mass. That's equal to 1 mole. Even here also given mass by molar mass of water 18, 1 mole. So how many gaseous product? 1. How many gaseous reactant? 0. There is no gas, dear all. Reactant is liquid. 0. So it's equal to 1 mole. So 1 into 8.314 into 10 raised to minus 3 into temperature. How much temperature they asking? Calculate the internal energy of vaporization at 100 degree. 100 degree mean 373 Kelvin. Okay, calculate the value of delta U, 37.56. See how many questions we discussed about delta H and delta U relation. Clear? So it's a sure question. Okay, delta H, delta U question. So practice all of you carefully. You will get the answer. Now one of the important question I am going to discuss here. Please carefully listen. The combustion of 1 mole of benzene. See, benzene, one question is there in NCERT textbook, one of the important concept where the way of presentation, actually it's a interesting one, but many things we have to write and present it, that's it. But carefully listen, all at least 2 time practice. The combustion of 1 mole of benzene. What is benzene? You know, C6H6, right? You know, benzene undergo, is combustion of benzene. So, benzene undergo combustion. What do you get? Carbon dioxide and water. Let me balance, okay? Let me balance. Here 6 carbon, so 6 CO2. Then 6 hydrogen, so let me write 3H2, so 6 hydrogen. Now only oxygen remain to balance. You know, 6 into 2, 12. 12 plus 3, 15 oxygen right side. 15 oxygen right side. Only 2 oxygen left side. What to write? If I write 15, 15 into 2, 30 comes. But we need only 15, right? So 15 by 2. 15 by 2 O2 means overall 15 oxygen, correct? So it is all 6 into 2, 12. 12 plus 3, 15 oxygen right side. Here also 15 oxygen now, right? Why? Because 15, if you are taking only 15, 15 into 2, 30. 30 oxygen by 2 means 15 oxygen. So this is the benzene undergo combustion. Yeah. Read all of you the question thoroughly. Combustion of 1 mole of benzene takes place at 298 Kelvin and 1 atm. After combustion, carbon dioxide, water are produced. Yes, carbon dioxide, water produced and 3267 kilojoule heat liberated. What do you mean by that? That amount of energy liberated. Liberated mean it's exothermic. You know, anyway, it's a combustion. Combustions are exothermic. You know, exothermic mean what is the value of delta H? Yes or no, dear all? What is the value of delta H? Delta H minus 3267 kilojoule per mole. Okay, kilojoule. That minus sign is enough to make the compound or the complete reaction, complete answer wrong. Okay, careful. Because they already said it's a liberated, means energy released. Okay, liberated. Good. Next. Calculate the standard enthalpy of formation of benzene. Means, what do you mean by formation? Mean forming 1 mole product, which is that benzene. How you can get benzene C6H6? 1 mole, 1 mole. What are the elements in the benzene? Carbon and hydrogen. How carbon existing? C. How hydrogen existing? H2. Balance all of you. 6C, 3H2. This equation we have to make it. This is the third question we are discussing this type. They will give you some data, we make into equation and we are making a new equation by the use of other equation. So this equation we have to make it, okay? We have only one equation now. Question not over, read it. Standard enthalpy of formation of carbon dioxide. What do you mean by enthalpy of formation of carbon dioxide? 1 mole carbon dioxide should form. How to make it? C plus O2 gives CO2. This energy they already given. See, standard enthalpy of formation of carbon dioxide and water. How you can make it 1 mole of water, dear all? What are the elements in H2O? Hydrogen and oxygen. How can you balance it? H2 plus half O2 gives H2O. These both energies are given. For carbon dioxide, it is minus 393.5. For water, it is minus 285.83 kilojoule. Okay. So, yes, we have total 1, 2, 3 equation. By using this 3 equation, we have to make this equation. Okay. You can pause the video. Just try all of you the answer. Later, you watch it. We need 6 carbon first. Where is carbon? Where is carbon? Carbon is in second equation. We need total 6 carbon, but we have only 1 carbon, right? So how to make it 6 carbon? That second equation multiply by 6. Second equation multiply by 6. So what you will get? 6C plus 6O2 gives 6CO2. So peacefully do it all of you. So what happened to delta H? Multiply by 6, right? Minus 393.5 into 6. Okay. So carbon ready. 6 carbon ready. Where is H2? Yeah, H2 is here. Third equation. We need 3 H2, right? But we have only 1 H2. So the third equation multiply by 3. If you multiply by 3, what it become? 3H2 plus 3 by 2 O2 gives 3H2O. Delta H will be 3 into minus 285.83. Done. Next, what do you want? Benzene. Where is benzene? First equation. We want benzene on product side. We have it is on the reactant side. So reverse the first equation. While you reverse the first equation, what it become? If you reverse, it becomes 6CO2 plus 3H2O gives C6H6 plus 15 by 2 O2. While you reversing the equation, delta H sign changes, it becomes plus 3267 kilojoule per mole. Take the sum of all this equation, all of you. Take the sum of all these 3. Let me, I'm going to cut here, okay, without space. No space here. I'm going to cut here. All LHS you see, all RHS you see. Okay. See dear all, I have 3H2O here, 3H2O here, cut. 6CO2, 6CO2, cut. And anything more to cut here, all of you. Have you observed 6O2 plus 3 by 2 O2 left side? What is 6 plus 3 by 2? 15 by 2, alright? So 6O2, 3 by 2 O2 is actually 15 by 2 O2. Yes, here also 15 by 2 O2, cut it. What is left? 6C. 6C plus 3H2. 3H2 gives C6H6. Are you getting the equation? Yes, but what is our final answer? Take the sum of all these delta H value. Take the sum of all these delta H value. It is nearly 48.5 kilojoule per mole. So what we did this in this equation, they given all statement question, all our equation, just like the state reactions are given, right? Reaction given in the term of words. We made every word the equations into the written equation, and we make a new equation by the use of other three. So dear all, try to understand the way. This is benzene undergo combustion. This is formation of benzene. This is formation of carbon dioxide. This is formation of H2O. By using this 1, 2, 3, we are making this equation. So the final answer is 48.5. Is it clear all? So directly and maximum try to practice again this chapter, okay? So these are the most important question from the chapter thermodynamics. Hope it's clear dear all. And statement wise study what is entropy, all other data also. So mainly we are discussing, going through the chapter. Here it is, what is system and surrounding, what is state function, path function, example, what are the different type of system, open system, closed system, isolated system, what are extensive property, intensive property, with example, what is first law of thermodynamics, second law, third law, statement of thermodynamics, the law, definitely they ask you, what is enthalpy, internal energy, Gibbs energy, and entropy, this heat capacity, single terms are there. Study all of you carefully. Numerical based question, delta H and delta U relation, CP-CV relation, and the Gibbs-Helmholtz equation, delta G equal to delta H minus T delta S. They will ask you when it is spontaneous and all. When delta G negative, reaction is spontaneous. When delta G positive, reaction non-spontaneous. When delta G 0, reaction is at equilibrium. When delta H positive and negative, delta H positive mean endothermic, delta H negative exothermic, and delta S when it is positive and negative. When entropy increases positive, when entropy decreases mean negative. Clear all of you? And sign convention and all study. When work done on the system positive, by the system negative, delta U equal to Q plus W, Q equal to MC delta T heat capacity equation, delta H equal to delta U plus delta NG RT, delta H delta U relation, delta HR calculated by sum of bond enthalpy of reactant minus sum of bond enthalpy of product, and so, or we can use enthalpy of formation of products minus enthalpy of formation of reactant. So study enthalpy of formation statement and all. So Hess's law of constant heat summation. These are the main important numerical and theory question from the chapter. Hope it clear all the question. If it did not clear me, just read the question and pause the video, just see the steps what we did that, and the final answer please try to cross check it, all of you, whether there is a mistake or not, please check it. So I hope you enjoy this session, and I hope it's clear. This all question you should practice before going to your school examination dear all. We'll come with again one another or important chapters. We will come in the, or we can meet in the other upcoming sessions. So thank you all, stay tuned. Thank you all, bye everyone.